Look up. You're standing at the base of a tower that disappears into the clouds. From the street, it looks like any other modern skyscraper, but almost everything above your head is wood. Not a decorative finish, not wooden walls, the structure itself. For more than a century, architects around the world followed one simple rule: never build a skyscraper out of wood. Not because wood is weak, but because it burns, it rots, it bends under load. And in an earthquake, every weakness becomes a risk measured in lives. So as cities climbed higher, wood was left behind. Steel and concrete built every skyline you know, which is what makes Japan's plan sound almost impossible. In one of the world's most earthquake-prone countries, engineers want to build a 70-story skyscraper made almost entirely of wood. On paper, it's everything modern engineering learned not to do. So why would one of the world's most advanced nations gamble a skyscraper on the oldest material we've ever used? And more importantly, what do they know that the rest of us don't? To understand what they know, you first have to understand why the rest of us gave up. Because we didn't walk away from tall wood by accident. We were forced to. It's tempting to think wood fell out of fashion because it felt old, primitive. But that's not what happened. And the real reason is far darker than old. We stopped because wood kept doing one thing no engineer could control. It burned. Not small house fires, but infernos that swallowed entire cities in a single night. London, Chicago, Tokyo itself. Once a city built from wood caught fire, there was almost no way to stop it. And every disaster reinforced the same brutal lesson. The taller you built with wood, the more lives you placed above the flames. So the world did the logical thing. It made tall wood illegal. Building codes across dozens of countries drew an invisible ceiling. Timber capped at around 6 stories, often less. Go higher. And the answer was simply no. Steel and concrete didn't just win. Wood was ruled out of the game. And that ceiling held for more than a century. Even today, after decades of engineering progress, the tallest wooden building on Earth rises only about 25 stories. That's the record. Now compare that with what Japan is proposing, 70 stories. Not a little taller, nearly 3 times higher than anything humanity has ever built from wood. So this was never just another engineering challenge. It was a rule written in fire, reinforced by tragedy, and eventually locked into law around the world. Which is exactly what makes the next part impossible to explain. Because if the case against tall wood was this strong, this settled, closed for 100 years, then something must have broken it. Something changed. And it wasn't the buildings, it was the wood itself. So when engineers say they can build 70 stories out of wood, the honest first question is this even wood at all? Yes and no. It starts as ordinary timber, plain planks, the kind you'd find at any lumber yard, but then something changes. Engineers take those thin boards and glue them together in layers, and the whole secret is in how they stack them. One version is called Cross-Laminated Timber, or CLT. Each layer is turned at a right angle to the one beneath it. Imagine plywood, but scaled up into giant panels thick enough to become entire walls or floors. Crossing the grain this way helps cancel out one of wood's oldest weaknesses, its tendency to split and bend in a single direction. Another version is called glulam. Here, the layers all run in the same direction before being bonded into massive beams and columns. And here's the surprising part. Pound for pound, glulam can rival, or even exceed, the strength of steel in certain structural applications. This isn't the wood that burned down cities. This is engineered timber, designed, tested, and built to carry the weight of a skyscraper. But here's what almost everyone gets wrong about this tower. It isn't wood instead of steel. It's wood and steel working together. Steel reinforces the building where it's needed most, while engineered timber carries much of the structure. It's a hybrid system combining the strengths of both materials instead of asking one to do everything alone. So at least on paper, the strength problem seems solved. Except strength was never the thing that made wood dangerous. A material can be strong, enough to hold a tower up and still be the reason everyone inside doesn't make it out. Strong is one thing, safe is another, and wood still burns. Let's be honest about the obvious objection. Yes, wood burns. That isn't a myth to knock down. It's the whole reason this tower sounds insane. So how could any engineer look at 70 floors of timber and call it safe? The answer begins with something that feels completely backwards. A thick column of engineered timber doesn't burn the way most people imagine wood does. Set a heavy timber beam on fire and something unexpected happens. The outside blackens into a layer of char, a dark, protective shell. But that char barely burns. Instead, it acts like insulation, shielding the solid wood beneath and helping it stay cool enough to keep carrying weight. In a strange twist, the fire creates the very barrier that slows its own progress. Now compare that with the material we've trusted for more than a century. Steel doesn't burn, but under extreme heat it softens, loses strength, and can buckle unexpectedly. Properly designed mass timber behaves differently. It burns slowly, predictably, and its char layer helps protect the structural core for a significant period. And this isn't just theory. Engineers have built full-scale timber rooms, packed them with furniture and extra fuel, disabled the sprinklers, and set them alight under worst-case conditions. In several tests, once everything inside had burned away, the fire eventually ran out of fuel it could reach and died on its own. The structure was heavily charred, but it was still standing, so maybe a wooden tower can survive fire after all. But there's a colder problem waiting, because in Japan, fire isn't what brings buildings down. The ground is, so the fire objection collapses. But it's replaced by something worse, the very threat we just named. In Japan, it isn't fire that topples buildings, it's the earth itself, and here the instinct is obvious. Steel and concrete are heavy, solid, immovable. Wood feels flimsy by comparison. So surely a wooden tower is exactly the wrong thing to put in earthquake country. Except physics tells a different story. In an earthquake, weight becomes the enemy. The heavier a building is, the greater the forces shaking it from side to side. Because engineered timber is much lighter than steel and concrete, there's simply less mass for the earthquake to push around. But being lighter is only part of the answer. The real innovation is what engineers do next. They design walls that are meant to move. Solid timber panels are anchored with high-strength steel cables running through their core. When the ground shifts, the walls are allowed to rock with the motion instead of resisting it. Then, as the shaking fades, the tension in those cables helps pull the structure back toward its original position. A building that bends, but doesn't stay bent. And they didn't just trust the theory. Engineers built a full-scale 10-story timber tower, bolted it to one of the world's largest earthquake simulators, and subjected it to more than 100 simulated earthquakes. What happened next is the reason engineers believe a tower like this can stand at all. Because it survived the fire. It survived the ground. Which leaves the strangest question of all. If wood can do all this, why isn't every city already built from it? Here's the truth this whole story has been hiding. The tower was never really about wood. Go back to the beginning, to the two materials that replaced it, steel, concrete. For over a century, they looked like the obvious answer, stronger, safer, more modern. But every answer has a cost, and this one's been hiding in plain sight. Producing cement alone releases billions of tons of carbon dioxide every year. Steel adds billions more. The very materials that let our cities reach the sky have become some of the largest sources of emissions on Earth. Every skyline you admire is also quietly a chimney. Now think about what a tree does. Its whole life, it pulls carbon out of the air and locks it inside itself. Burn it or let it rot, and that carbon escapes. But build with it, and the carbon stays in the beams, in the walls, for as long as the building stands. So this tower isn't just cleaner to build, it becomes a place to keep carbon out of the sky. A city that behaves like a forest. And that's the vision driving the company behind it. Sumitomo Forestry has worked with wood since the 17th century. For its 350th anniversary, it proposed something with a message built in: a tower, 350 meters tall. 350 years working with trees. 350 meters reaching back into the sky. Which makes one fact almost impossible to explain. If the idea is this good, why hasn't a single shovel touched the ground? So why hasn't a single shovel touched the ground? Because the honest answer is the one nobody in the excitement wants to say out loud. This tower doesn't exist yet. Not as a building, not as a construction site. Right now, W350 is a plan. A vision on paper backed by research, but not yet a place you can stand inside. And that matters because it's easy to make a wooden skyscraper sound inevitable. It isn't. Look at what actually stands today. The tallest timber buildings on Earth rise to around 25 stories. Real buildings where people already live and work. That's an extraordinary achievement. But it's still a long way from 70. The gap between 25 stories and 70 isn't just another engineering milestone. It's the difference between what's already been proven and what still has to be proven. Fire, earthquakes, structural performance. The ideas are promising, but they still have to work at a scale no wooden tower has ever reached. So the technology is real. The direction is real. But the finished tower is still a promise, not a fact. And that forces a harder question, one that has nothing to do with whether we can build it. Because can we was never the same as should we, even if every problem gets solved? Should we really build our cities this way? So, brilliant idea or impossibly expensive dream? Both. And that's the honest answer. Start with the money. A tower like this is expected to cost roughly twice as much as a conventional skyscraper of the same size. For many developers, that's enough to end the conversation before it even begins. Then comes the fine print nobody likes to talk about. Insurers remain cautious about buildings this tall with such a limited track record. Timber also has to be protected from moisture throughout its life. And in many countries, building codes still weren't written with a 70-story timber tower in mind. There's a quieter problem too. A tower like this swallows an enormous volume of wood, and it only stays green if that wood comes from forests replanted as fast as they're cut. Get that wrong, and the carbon story falls apart. And remember, this was never going to be pure wood. Steel remains an essential part of the structure. Maybe the most honest description isn't a wooden skyscraper, but a hybrid tower that pushes wood as far as today's engineering allows. None of that makes it a bad idea. Great engineering was never about perfection. It was always about compromise. So which is it? Maybe the wrong question. So step back. Forget Japan. Forget the tower. Forget wood. Because the real story was never about a building. For more than a century, we told ourselves a simple story about progress. That moving forward meant inventing something new, a stronger material, a smarter machine, something the world had never seen. Steel and concrete became symbols of that story, and together, they built the world we live in. But this tower asks a different question. What if progress isn't always about inventing something new? What if sometimes it comes from looking again at something we'd already dismissed and realizing we never truly understood it? The wood didn't change. We did. The same material we ran from for 100 years was waiting the whole time. Not weaker than what replaced it, just misunderstood. It took new eyes to see it. And that's the part worth keeping, long after you forget the height and the numbers. The biggest breakthroughs won't always come from something brand new. Sometimes they come from looking again at what was already there. The future of our cities may not begin with something humanity has never built before. It may begin with something we've been surrounded by all along.